This is the second videotape of probability. So I was doing an example of simple probability, and this is another example. Let's say we roll one die 2 times. What's the probability of obtaining a 2 and then rolling again and obtaining a number greater than 4? All right, let's figure it out. The simple probability formula is probability A and B equals P A times P B, and there's the that equals P 2 and die greater than 4. Don't forget it's the events, and then P2 times P die greater than 4, and here's the formula. So P2 and die greater than 4 equals P2 times P die equals greater than 4 equals 1 divided by 6 times 2 divided by 6. Times 2 divided by 6 is 2 divided by 36. When we reduce that, it's 1 divided by 18, or 5.6%. And so P2 and die greater than 4 equals 5.6%. So we have a probability of 5.6% when we roll the die twice, and we get a 2 the first time, and then the probability of obtaining a number greater than 4 is 5.6%. This is conditional probability, and don't forget, conditional probability is you have to have something that happens first. So let's say we draw 2 cards from a deck, but don't put the first card back in the deck before drawing the second card. So we're now dealing with 51 cards. So what's the probability of first drawing the king of clubs and second any other club? All right. The conditional probability is P A and B equals P A times P B A. And so let's go ahead and take a look and put some numbers in. P, king of clubs and any club, given that the first draw was a king of clubs. The P, king of clubs, times the P, any club, given that the first draw was the king of clubs. Okay, and let's continue it. So it's the first one is 1 of 52, and so there's that. The first draw was a king of clubs, and that equals 12 divided by 51. And when we reduce that, it's 4 divided by 17, because only 12 clubs and 51 cards are left in the deck after the first draw. And then the P, king of clubs, times the P club, given that the first draw was a king of clubs. So here are the numbers. It's 1 divided by 52 times 4 divided by 17 equals 4 divided by 884 equals 1 divided by 221. So we have a 0.5% chance. Here's an easier example. Let's say we roll 2 dice at once. What's the probability of obtaining a total greater than 11, given that you got a 6 on the first roll? All right, and here's the combinations that you could get. Okay, so P, total greater than 11, first die equals 6. Okay, conditioned by the fact that the first die equals 6. So here they are. So these are all the combinations. If the first roll was 6, these are the combinations that you could get on the second roll. You could have 6 different ones. So here they are, and here are the numbers. So 1 divided by 6 equals 17%. In simple probability, events A and B are independent from one another. In conditional probability, events A and B are dependent. All right, B is dependent on what happens in A. So the probability of event B is conditioned by the outcome of event A. All right. Estimating the probability of events A or B works like this. If A and B are independent, all right, example, a deck of cards, n equals 1, what's the probability of drawing the king of clubs or the king of hearts? All right, well, how many are in there each? It's 1 of 52 of each. All right, so there you go. It's 3.8%. And this is pretty simple math. And then estimating the probability of events A or B if A and B are dependent. All right, take a look. We're actually subtracting P, A, and B. Why? Because when PA and PB are added together, the occasions on which A and B both occur are counted twice. We need to subtract the cases in order to adjust for the bias. And I don't want you to get too scared of probability because it's a very small part of what we're going to be doing, and it's just something that you should try to understand to continue on with a greater understanding of statistics. Okay, estimating probability of events A or B if A and B are dependent on one another. All right, this is the conditional probability. So let's take the same example again. What's the probability of drawing a king or any club out of a deck? All right, and there's the formula. PA or B equals PA plus PB minus PA and B. All right, so the kings, there are 4 of them, 4 divided by 52, and the clubs are 13 of them, 13 divided by 52. So here's the math, and just remember, these are just recipe formulae. All right, so you just plug the numbers in. 4 divided by 52 times 13 divided by 52 equals 52 divided by 2704 equals 1 divided by 52. And here's the bottom line. You get 31%. Just plug in the numbers. That's all you have to do. Here's the probability of a king plus the probability of a club minus the probability of a king and club. All right. So in summary, 2 things you have to take into account when estimating probabilities are your events independent or mutually exclusive? They don't affect each other. Are you looking for the probability of all events occurring and the product, or for either one of the events occurring, which is the or sum? Okay, and these are called Boolean operators, and or. You don't have to know that. Don't worry about it. Don't be frightened of this. 4 possibilities, okay, are 1 independent and, 2 dependent and, 3 independent or 4 independent or. Okay, and don't be frightened by these. This is important. A probability in percent can be no less than 0% and no more than 100%. All right, and we want to talk a little bit about the unit normal table because it has to do with z-scores. Okay, so this is the unit normal table, which is found on page 725 of your book, tells us which proportions of the normal distribution are located in the body of the graph, the larger part of the distribution, and which parts are in the tail, the smaller part of the distribution, for a series of possible z-score values. Okay, and this is it. The unit normal table in column A, you're going to see this in your book, which is here, are the z-scores. Okay, column B is the proportion. It's this part in the body of the normal distribution up to the z-score value. So let's say the z-score was here, and so B would be the value for the proportion in the body. And these are just things to look up when we're working with them. Column C, the proportion of the normal distribution that is located in the tail, which is over here, and beyond the z-score value. So here was before the z-score value, here's the z-score, and here's after the z-score value. And in column D, over here, it's showing the proportion between the mean and the z-score value. So here is the mean, which is going to be 0 because it's normalized, and here is z, so this is the value that's going to be in here. All right, and next week we'll be looking at part 2, statistical inference or inferential statistics. Up until now we have been doing something called descriptive statistics, and I realize that conditional probability could become relatively complicated, and I don't want you to be frightened of that, because we will not be spending a lot of time on probability. What we are looking to do is just touch on it and then move forward, because I just want you to know what probability is, so that when we hit p-values later on, you'll have an understanding of them. Will we be using probabilities very much in statistics? No, not really, because we're going to be working with test and more applied statistics than theoretical statistics. So going forward, don't be frightened of those probabilities. Okay? And next week we'll do part 2. So tune in to the next video that I'll be doing, which is a review of last week's homework. And if you have any questions, as usual, please let me know. And, see you later.